This is Mr. Smith, the Academy for Allied Health. We are moving into Chapter 2 in chemistry using our Glencoe book. Chapter 2 is analyzing data. With Chapter 1, Chapter 2 is one of the more important chapters that you want to look at. Mathematics, I find that these early pieces we tend to try to rush through, we tend to try to gloss over. But the reality is you want to make sure that you understand them very well. You want to understand what they're saying, because this is going to serve as the foundation that you need to feed off of on your way through the rest of the course. 4 sections to this chapter. We are going to start in this video with units and measurements. The one following will be scientific notation and dimensional analysis. Third will be uncertainty in data. And then finally, representing data is section 4. We will start off with units and measurements. We need to define these and we need to know these. So we're going to look at the SI base units for time, length, mass, and temperature. We're going to define what they are. We're going to explain how adding a prefix changes a unit. We're going to compare derived units for volume and density. Some review vocabulary to keep in mind. Mass is a measurement that reflects amount of matter an object contains. A lot of new vocabulary, but we're going to look at this, and I know you're saying to yourself, hey, wait a second. I've seen this. I've done this. I've looked at this in math. I understand these. From a mathematical standpoint, I am sure that you do. However, we're now going to deal with them in chemistry. And from the chemistry standpoint, we need to be sure that we know what we're talking about, converting them, doing those things correctly. Part of the question is why? Why do I need to do this? Well, I was hoping to help you with some of that. That's why I put up the video about the NASA launcher landing and the video and the news stories concerning the one that crashed 15 years ago into the planet. Had everyone adopted and utilized a uniform system of units, that accident would not have happened. The fact that it did happen, given what I'm going to teach you now, you should be asking yourself that query, and perhaps there needs to be a push into the area of making a metric system our system here in the U.S. Okay, the System International Unité deals with an international system of units. Basically, you could say, hey, this is the metric system, and you're kind of right. Yes, this is the metric system. It actually started in 1960. There were a number of conferences going on to come to an agreement so that we would have a uniformity. Well, at the last minute, why is this not a surprise to anyone? England and the United States balked and refused to sign on to this metric system. Although it did become something that needed to be taught side by side with the imperial system in United States schools, it was not given the emphasis that it should. These days, it's being given a lot more emphasis, and it's certainly being talked about a lot more in colleges, but it still doesn't have the we're going to do everything in kilometers type stuff that it should. In my opinion, had the United States gone ahead and gone to this, you would not have wasted $150 million in 1998 crashing a rover into Mars. But that's just me. There are 7 base units to the system that we're going to work on. There are a few others. The base unit is the system of measurement that's based on an object or event in the physical world and is independent of other units. I say that there's others because in this list is incomplete. You have electric current, you have luminous intensity. There's no energy in here, and energy has a base unit in the SI as well. Plus there's momentum and a couple of other things, but we'll get into those when we get into physics. So these 7 certainly work for chemistry. Time, length, mass, temperature, amount of a substance, electric current, luminous intensity. You want to know what these base units are? We will talk in depth about the mole in a later chapter. We will talk in depth about the Kelvin for temperature when we get into heat. And when we get into electrochemistry, we will talk about electric current. The candela, I may try to introduce that when we start talking about light and electron spectrums and all that kind of thing. We'll see. These are the regular prefixes that you can expect to encounter during the course. And I would say that you would expect to encounter regardless of what you're going to enter into in your careers. So, except maybe for tera, you would add tera to this at 10 to the 12th. I believe that there's a 10 to the 15th, but I don't know what it is. Then pico is 10 to the negative 12, and there's one that it's called the femto, I believe, that is 10 to the negative 15. The SI unit for time is called the second. It is based on the frequency of radiation given off by a cesium-133 atom. That's actually how we determine what a second is. The idea, it used to be an event, but we don't want to do that anymore. Scientists have decided that they actually want to try to put it to some physical event that occurs in the universe. The meter is the distance that light travels. If you look at it, light travels 3 times 10 to the 8th meters per second. So therefore, the meter would be the distance light travels in 1/300 millionths of a second. Okay, because if you look at those two together at the speed of light, it would go a meter in that amount of time. The SI base unit of mass is the kilogram, about 2.2 pounds. This is an object, although that might change. They're looking into a couple of events trying to determine a different way to set the standard for the kilogram mass. The reason being the current kilogram mass, which is a sphere, it's a mixture of nickel and iridium. One of its issues, it needs to be polished to a high shine. And it's kept in velvet and wrapped up and kept away. And it only comes out every 4 years when manufacturers of balances go to France, where it's located, and they calibrate their balances from that. And then any other balances they make use that calibration for the next 4 years. There is concern that the constant polishing is eroding part of the sphere, which means, of course, it's no longer has the same mass that it started with if you're wiping off or eroding pieces of the sphere off of it. And therefore, if it's becoming, it's almost getting noticeable that it's shrinking. And if that happens, then the kilogram isn't really valid. So they're trying to come up with a different way to demonstrate that mass. So far, they haven't changed it as far as I can tell, but I know that they keep looking. The base unit for temperature is the Kelvin. This is done because 0 Kelvin is considered absolute zero. And that is where the theory goes that of collision theory and the theory of particle movement. Absolute zero is the temperature at which there is no possible movement of particles. It can never be reached because the act of, this goes back to Heisenberg and his uncertainty principle, the act of observing the temperature for absolute zero means that you need to move molecules to read the scale, and therefore you can't get to absolute zero. try that one a couple of times. Play that back a little bit and try to run your brain around that. But it'll make sense to you. It doesn't make sense the first time around, but the second or third time it'll start to make sense. It all deals with the uncertainty principle and the fact that you affect a molecule by observing the molecule. We can talk more about that when we get into class. Okay? We do have Celsius and we do have Fahrenheit. In the lab, you are going to use Celsius. When you watch television, you're going to be given everything in Fahrenheit. The Fahrenheit scale belongs to the imperial system. The United States has kept the imperial system. That's where we are. Aside from the base units, you also have derived units. Derived units are usually combinations of base, or in the case of one of them that we're going to see coming up, it is considered conventional or a local unit that gets utilized. In volume, the more convenient or the local unit that we like is the liter, but it is the cubic meter that is considered the standard, because you're taking, for volume, it's derived. It is taking the meter and taking the three parts, length, width, height, to come up with volume. So it's the cubic meter. Density is also derived. It's mass over volume. So mass, it has a base, but volume is, of course, derived. And its units that we use in chemistry is grams per cubic centimeter. It's standard. There is an SI standard, even though it's a derived unit. There is an SI standard for density of kilograms per cubic meter. The equation for density, which we must remember, is mass divided by volume equals density. And that will come in very handy because density is what's known as an intrinsic property of an element. It can help you determine, along with the other properties of the element, what element you have. All right, that's section 1. Let's do some quick assessment, see what it is that we know. Which of these is a derived unit? It is, of course, the liter. And what is the relationship between mass and volume called? That is, of course, density. So if you've gotten those two, chances are you've done very well. It's not a hard section to understand. However, you do want to keep it in your mind and refer to it and know it and own it. All right. We're going to be moving on next to section 2. Thank you very much.